Welcome everyone. My name is Panu Pasanen. It's my pleasure to welcome you to today's webinar on low carbon aluminium as a solution for sustainable construction. We are organizing this webinar together with Rusal and with Jerome Lucas from Rusal, who will be also presenting today. Quite possible that some attendees will still be connecting. However, we will not delay further the start of the webinar. And I would just like to inform everyone who's interested that we are recording the webinar, so that if you have colleagues who would be interested, they can request for the recording afterwards. So without further ado, I'll proceed to introduce the speakers. And yours truly is Panu Pasanen. I'm the CEO at Bionova/OneClick LCA. I've been working on construction sector, lifecycle assessment and sustainability for about 2 decades now, and predominantly with businesses, also a fair amount with governments to shape low carbon policies. And I'm working with the different players in the industry to support the low carbon transformation. It's my pleasure also to introduce Mr. Jerome Lucas, who's the Marketing Director for Sustainability at Rusal, who's also has an extensive experience of over 20 years in the business, and he's co-founder of the Aluminium Stewardship Initiative. And he's working on his side to accelerate the transformation of aluminium industry to zero carbon. And he's went to a Grande École in France, as you can see, and also completed an MBA in Paris. We start the presentation so that I go first and present the key findings of the white paper, which we released earlier in the spring. And then Jerome will explain to you from the point of view of the industry, what does this all mean? How do we put this into practice? And also, what are the challenges? Like, what does have to happen yet? We are also welcoming questions and hope for an interactive webinar. And the platform has a question and answer functionality, which you can use, and you can write your questions into the chat at any time, but the plan is to take the questions collectively in the end. So with that introduction, we are going forward. And I'm just introducing ourselves really briefly. So the company name is Bionova. We are more known under OneClick LCA brand. We are a construction carbon and lifecycle assessment company, predominantly software and data provider. We are world leading in the construction LCA space with the platform used in more than 7 countries. And we have about 30 people working in-house on this platform. We also do selective high impact projects, of which this is one. Most of the projects like this we do together with regulators or international organizations, but we are quite happy with this work we did with Rusal. And some of our clients you can see here. So with that introduction in place, let's go into the aluminium and why this aluminium demand and why this climate impact from aluminium, right? I'm not going to read you the law, but just to introduce key terms for those of you not familiar with this. Embodied carbon basically means total greenhouse gas impacts from a material used in construction through the whole life cycle, right? Life cycle assessment is a method based on science and international standards to assess environmental impacts also through the life cycle. And we use 2 terms for aluminium specifically in this presentation. First of them is primary aluminium, which is made by smelting bauxite or nepheline ore, as opposed to recycled aluminium. And low carbon aluminium means primary aluminium made with renewable energy, as opposed to aluminium made with fossil energy or recycled aluminium, which has constrained availability, right? So these are some of the terms we use during this presentation. Hopefully you're comfortable with them. So architects love aluminium, right? It allows you to do a lot of things: durable, flexible, easy to process, lightweight. So it's sought after as a material. And the key problem here is that it's very energy intensive. So you need about 14 megawatt hours of electricity per ton of primary aluminium, which works out to about 20 kilos of CO2 per kilo of primary aluminium. And when you put it in buildings, when you take it out, you can reuse it, which is great. The energy intensity still remains a problem, mainly because it's used in huge quantities. And at the planetary scale, aluminium creates about 1 gigaton of carbon. And gigaton is a big number, right? So it's basically 1, 9 zeros, and a ton, right? And that basically means about 80 million Western citizens total greenhouse gas emissions, right? So if you take Germany broadly, right, or California, that's what it means. So we have Germany or California, and then aluminium, about the same size in terms of global warming impacts. Not exactly, obviously, but just to put it there in terms of what it means. And it doesn't really mean like global citizens' lifestyle, it means the Western lifestyle, which is much higher in carbon than those life cycle lifestyles of people in countries which lesser levels of income, for example. And recycling, as it was already mentioned, is a great solution. It uses only 1/20th of the electricity compared to the primary aluminium. But the thing is that because aluminium is sought after, it can't cover the demand. So we basically have a solution, but only to 30% of the problem. So we need a solution to the 70% of the problem. And we need other sources for low carbon aluminium. And if we look at the primary aluminium, the average primary aluminium manufactured in China, which is obviously a big source of demand for construction, has high impacts, around 20 kilos per kilo. And it's a fair share of the global export as well. Then if we go to the primary aluminium used globally and look at the average, it's a tad less, so about 17 kilos per kilo in terms of carbon impacts. And then if we look at the low carbon aluminium as it was defined in this paper as primary aluminium made with renewable source of energy, Carbon Trust, which is a UK government undertaking, has proposed a limit of 8 kilos per kilo of aluminium. That's the limit. And a typical market product is 6.7 kilos, more or less, per kilo of aluminium. So we have a very significant scope for emissions reduction through using better aluminium. And obviously the key question for us is, how do we get there? And how can you, of course, if you are one of the parties who are specifying and sourcing it, how can you make this applied in your projects? And then looking a bit more in what this application of this product or this material in construction means. Embodied carbon, or to recap, the carbon from construction materials during their lifetime, is considered in a vast and growing number of standards and regulations. This is a review from 2018, but it's still broadly good. So all the green pies or green parts of the pie represent the number of standards or regulations to do with green buildings, which do consider embodied carbon or carbon footprint of materials in one form or another, right? And correspondingly, the gray one is the part that doesn't. And you can see that all the international systems, and virtually all European systems as well, is part of the picture. So it's looked at in almost all approaches used. In North America and South America, it's in more than half of the systems. In North America, it's higher than South. South America only has a few systems. And in Asia Pacific, it's still about 35%, 40% of the total systems, but growing. Where it hasn't yet broken through is Middle East and Africa, which of course also suffers from different types of sustainability problems, including, civil unrest and that kind of problems, which are possibly of more fundamental level than what we are dealing with here. In every case, we can see this becomes more and more important and is already dominant or mainstream solution in anything that's connected with sustainable construction. And in the research, we did include 2 case studies. One of them was graciously provided by Stock, who are sustainability experts working in real estate market based out of San Francisco. They provided us an educational building, about 140,000 square feet or 13,000 square meters, educational building, timber framed, and using aluminium support systems for stone cladding, vertical fins, composite wall panels, metal panels, and curtain wall frame. And the life cycle assessment from Stock shows that in this project, 42% of the embodied carbon was caused by aluminium. They performed this life cycle assessment over 50 years for structure and enclosure of the building, so it didn't include finishings and building services, right? And obviously, this is partly because it's a wood frame building, or largely because it's wood frame building. All the same, low carbon aluminium, depending on the assumptions that we use for the specific replacements done, can reduce embodied carbon by 18 to 23% for this building structure and enclosure. Also, it's not desirable in this project to replace aluminium with another material because it's providing desirable properties. So, sustainable project otherwise, using low carbon aluminium can be essential. Of course, more typical commercial buildings are made with concrete, and we did actually a review of a bit over 1,000 different commercial buildings, and we screened out all the ones which hadn't used aluminium. Of course, you could use other materials, right? And we identified a set of 527 commercial buildings. And they were predominantly in Europe, and it's all real projects calculated with one-click LCA. And in these projects, the average share of aluminium from the total embodied carbon was between 5 to 13%. And they used about 5 kilos of aluminium per square meter of building, right? And in this case, low carbon aluminium can reduce embodied carbon by up to 7% for this category of buildings. So between 2 and 7%, depending on exactly which parts in the buildings are made with aluminium, right? We are talking about quite significant opportunity there as well. Of course, it won't do much for the buildings that don't use it, but then when it's used because it provides something that's desirable and that can be solved with something else. It's also possibly worth noting that quite a few of these commercial buildings already do use low carbon aluminium because they see the importance of it. So it serves to prove the importance of this point. We did also tenant improvement project case. So in this case, we were looking at highly circular office retrofit in Finland, and the project didn't touch any external parts, and it was reusing a lot of materials, including some of the glass aluminium partition walls. However, as part of the project, additional ones were sourced. And in this case, low carbon aluminium reduced impacts for the case by 6% from the embodied carbon. And had the project not reused so many of the, partition walls, obviously the share would be higher still. We can't give you a general guideline for what's the low carbon aluminium share in renovation projects because all renovations vary, obviously. But what we can say is, in a way obvious, is that where aluminium is used, low carbon aluminium is a significant carbon impact reduction driver for the project. So those were the 2 case studies detailed in the report itself. And then a few words for those of you who might be in the manufacturing side of things. And why should you care, right? It's a good question. And Saint-Gobain, which is the world's leading construction product supplier, has done research on the market desires, and their research shows that 72% of the customers, or their customers, which is probably the same as your customers, expect manufacturers to produce more sustainable construction materials, right? So if you care about your customers, that should be a reason. And it has a significant impact. If you are making products which use aluminium, substituting primary aluminium with low carbon aluminium has a significant carbon reduction impact. We did a few cases which included partition walls, curtain walls, aluminium windows. All the details you can find in the white paper, and you can find the scenarios. But what we can say is it has a significant impact in the order of 30% to 1/3 would be about fair. Of course, if you start from a basis where you are substituting low carbon aluminium A with low carbon aluminium B, it probably won't make that type of difference at all. But if you are considering substitution of primary aluminium with low carbon aluminium, you have a really great progress potential there. All this and much more can be found in the white paper. White paper, it's available in English and I think 4 Asian languages, none of which I have the pleasure of speaking, so knock yourself out if you master one of them. It's on our website, and yeah, that's the presentation for my part. I'm handing over to Jérôme, and I will just change the presentation real quick to allow him to get to speed. Jérôme, whenever you are ready, and maybe you can just tell me when to progress the slides. I will not speak, but I can progress them for you if that's convenient.
Okay, thank you, Panu. Can you hear me well?
Loud and clear.
Super. Good afternoon, everyone. It's a pleasure for me to be here with you and to share the case of low carbon aluminium for green buildings. And thank you, Panu, for your great presentation and study on the case for low carbon aluminium. Let me make it clear about the climate urgency that we are facing right now. So the world is producing 50 gigatons of CO2 per year, and scientists are very clear that this needs to come to zero by the end of the century if we want to continue to live on a planet that is acceptable for human being and biodiversity. Now, the importance of carbon emissions in the building sector is also very important. The global urban population is expected to grow by over 2.5 million tons, and for all those people to have a good space to live, it will require a lot of building, a lot of concrete, a lot of steel, and a lot of aluminium, and it could need over 100 gigaton of embodied energy. Panu mentioned earlier, gigaton is a lot. It's 1 with 9 zeros. So imagine 100 gigatons. So that's 2 years of total greenhouse gas emissions that may be required by the construction sector by 2050. So finding all the ways to reduce the carbon footprint in building is very important. So in the aluminium industry, and Rusal wants to propose solutions to that challenge. Let me say a few words about Rusal, who we are. We're the largest aluminium producer outside China. We are a worldwide company with operating in 12 different countries, and most of our aluminium is produced actually in Siberia, in Russia, with the fortunate access to a large network of hydropower plants. Therefore, we produce aluminium with a much lower carbon footprint than the average of the industry. And we have launched a brand, allow for aluminium low carbon, that is guaranteed of less than 4 tons of CO2 per ton of aluminium. That's the emissions measured at the smelter, and that's guaranteed of less than 8 tons of CO2 from cradle to gate. And we have an actual average of 6.7 for our allow material. Next slide. Just a few words also about what we're doing in the climate space. Not only we produce the largest amount of low carbon aluminium in the world, because we have access to hydropower in Siberia, but we are also working on reducing all the other sorts of greenhouse gas emissions in the different processes to produce primary aluminium, essentially at the smelters. And we are working also on carbon-free technologies, which is the holy grail of this industry, and investing over 500 millions of dollars in the past 5 years to generally improve all our environmental impact. Next slide. I need to share with you the landscape of the worldwide aluminium production for aluminium. So the world is producing 65 million tons of aluminium, over which over 75%, 3/4, is produced with fossil fuel based energy, essentially coal, and essentially in China and India, and to a lesser extent in Middle East with gas produced energy. The rest of the world, there are 3 key regions who are producing aluminium with hydropower and renewable energy. The largest one is in Russia, Northern Europe, and also Canada. So next slide. What does it mean in terms of the environmental footprint and the carbon footprint of aluminium? As Panu mentioned earlier, producing aluminium is extremely energy intensive. It requires 14 megawatt hour of electricity to produce 1 ton of aluminium. Therefore, it's easy to understand that depending on how the energy is produced, if it's produced from coal or from renewable energy, of course, the carbon profile is completely different. So here you have a view of the carbon footprint emission at the smelter. So it's on the left, hydropower. You have emissions that are less than 2 tons of CO2 per ton of aluminium. If you compare with coal, 15 tons of CO2 per ton of aluminium. So those numbers may be a bit smaller than the ones presented by Panu just earlier, but because it's only the smelter emissions. Panu was mentioning about the full carbon, the full scope carbon footprint from bauxite to the casting of the material. So it makes a big difference. Therefore, the industry, next slide, please. Therefore, the industry and few producers, including Rusal, but not only Rusal, which is a good news, have launched to the market green aluminium brands, which is essentially defined by aluminium produced with renewable energy and essentially by hydropower. And it gives a significant advantage in terms of carbon footprint, as you can see on this slide, on the part comparing the carbon footprint of Boaz, one of the Boguchansky, one of the plant of Rusal, with the world average. So Rusal with the brand Allow and other producer are putting on the market certified low carbon aluminium with independent verification statement to empower our customers, the supply chain, to measure and reduce the carbon footprint of their own products. So it applies to the construction sector, but also to other sectors. As you know, aluminium is also widely used for automotive, for packaging, beverage, electricity, cable manufacturing, and electronic equipment. So all those sectors are more and more interested in making sure that the aluminium that they are using is as low as possible in terms of carbon footprint. We mentioned about recycling. Of course, recycling needs to be maximized. The interesting case about aluminium is there is a growing demand. Aluminium is highly recyclable, infinitely recyclable. However, most of the aluminium is used in application that last for very, very long time. Buildings, 50, 70, 80, 100 years. So the aluminium that is in a building right now does not come back as recycled product to meet the growing demand. So therefore, there is still a need for aluminium that is produced from extraction of natural resources. And this aluminium needs to be as low carbon as possible. Next slide, please. A few words about the Aluminium Stewardship Initiative, which is very important because together with the carbon footprint, the other aspects of sustainability, as you know, there is a wide range of topics that needs to be considered for sustainable productions, and not only environmental matters, not only waste generations or biodiversity at the mine, but also human aspects such as protection of indigenous people and business ethics. All those aspects are covered by a wide standard, the only standard for responsible production and consumptions that is applicable and available for the aluminium industry, ASI, the Aluminium Stewardship Initiative. So the ASI is not necessarily a standard for low carbon aluminium, but it's a standard that covers all the other aspects. And the good thing is ASI is now linking and developing collaboration and partnership with green building standards, and for example has been recognized as a responsible sourcing scheme for the BREEAM, and therefore for real estate developers and construction companies that are using ASI certified material, they have an opportunity to actually gain points, and for the case of BREEAM is up to 5 points in the BREEAM standard. So of course Rusal is also ASI certified, and therefore I would say that the most advanced sustainability value proposition in the aluminium sector is low carbon plus ASI certified. Rusal is one of them. The good thing to know for people who want and need to source aluminium, we're not the only ones. So there is a variety of different sources for low carbon aluminium and also ASI certified. Therefore, there is a growing supply and a growing demand to meet and to help the supply chain to decarbonize. Next slide. I'd like to elaborate a bit on the big challenge looking forward of our industry, the aluminium industry, as all industries. We are no exceptions. We have an urgency to decarbonize, and the good news is on paper, on theory, it's possible. the solution exists. There will be a lot of efforts. For the case of the aluminium industry, the key thing will be the decarbonization of the electricity generation that is needed to produce primary aluminium. Also, there are a lot of efforts that needs to be done in retrofitting existing production. The bad news is it's billions and billions of investments, and there is no business case right now. Until carbon taxes or carbon regulations are playing on a level playing field across all the countries worldwide, unless there is no real recognition from the consumers that low carbon aluminium are required, it's very difficult for the business. It's very difficult for producing company to make the business case to invest and decarbonize. Therefore, it is so important to share the view. We share our view that low carbon aluminium is necessary, and anyone who needs to buy aluminium should take his responsibility and consider to specify low carbon aluminium as a preferred source to produce its building, or to produce its car, or the beverage can, because that's the only way that the industry will be moving. If there is a recognition and an award, I would say, for low carbon aluminium. Next slide. So, just would like to finish on a few more generic things that the industry and also particularly Rusal, our company, are doing to drive this industry and towards a low carbon and eventually a zero carbon industry. Rusal has recently published a green aluminium vision that is available on the Rusal and EN Plus group website. EN Plus is the mother company of Rusal. Rusal belongs to the EN Plus group. So beyond the commitment to reduce our emissions, to promote a low carbon aluminium brand, we are actively also promoting carbon footprint transparency. Working, for example, with the London Metal Exchange to make the disclosure of carbon footprint by producer a mandatory requirement, so that consumers can have a clear choice of suppliers and materials when they decide which material to use. Working also with life cycle assessments, software, for example, that needs to be clear in differentiating the different source of material that are available, and the software suite by Onova One Click is doing a great job in the building sector for that. So there's a lot of things that needs to be done. Rusal is participating and shaping the agenda for the decarbonization of the industry, and working in partnership with customers to, let's say, to drive more consumption of low carbon aluminium material. Of course, recycling is part of the story. Aluminium has the great story because it's one of the most recycled material. However, there is not enough recycled material to meet the growing demand. Next slide. One slide to mention also were the fact that there are different initiatives in this industry in the world, to collective initiatives that are driven by industry association, that are driven by the Aluminium Stewardship Initiative, the Standard for Responsible Production and Consumption of Aluminium. And also here, I mentioned the World Economic Forum, who is also a platform to engage the industry, the regulators, the governments, the politics to find together the solutions to accelerate the transition towards the low carbon economy. So this platform has been mandated by the United Nations and is working with the 7 what they call hard to abate industries that are industry like the chemical industry, the steel industry, the cement industry, the aluminium industry, the aviation industry, and others that are working together to meet the challenge of the decarbonization. So, in essence, that's where we are. Maybe if you can jump right to the next slide. And yes, as the industry needs to decarbonize, as the aluminium industry put forward proposals for low carbon aluminium, there is a very important step, immediate step that needs to occur in the company, in the supply chain, is more carbon footprint transparency across the supply chain. So it's not acceptable for anyone in the industry nowadays not to know about the carbon footprint of what is doing and what is buying, and not to disclose to the immediate next customer in the value chain its carbon footprint, so that at the end architects or consumers that are buying cars need to know or to be able to know the carbon footprint of what they are buying and influence the choice to accelerate the transition of this of our economy. This is basically what I wanted to share with you. You can go to the next slide as a finishing slide.
Maybe I can just clarify. I think you mean LCA stands for low carbon aluminium on this slide, just not to misread what you mean here, because of course it could also be read as life cycle assessment.
Yes, that's right. Thank you, Panu. Low carbon aluminium, life cycle assessment, 2 different LCAs, very important and relevant in this discussion. Thank you, Panu.
Thank you, Jerome, and many thanks for everybody who sent questions. So we have 6 questions received so far, and I have one, I think, which goes to Jerome, and the question is, which 3 production sites in Rusal are ASI certified?
So currently we have 1 smelter ASI certified, which is the smelter of Irkutsk in Siberia. We're working for the certification of 5 other smelters, including the 2 big smelters of the Rusal group, which are individually over 1 million tons of production. And we aim to have, let's say, the vast majority of our production certified by end of this year.
Thanks. There is another question whether Rusal have produced EPDs for products which are available within 1 click. Maybe I could answer that. Yes. So the EPDs are being created as we speak, and they will be available before end of the year. And if I may plug a little bit, they are made using 1-click LCA pre-verified EPD generator, which is also applicable to products made using low carbon aluminium, so derivative products.
Yeah, so Rusal has mandated Bionova for the creation of its EPDs.
Jerome, a question for you. What is the impact of maximizing recycling rates on 2040 carbon scenario?
The impact is high, because the recycled aluminium, assuming it's coming from post-consumer sources, have actually the benefit to take a carbon credit that is starting from 0. Of course, the carbon footprint of recycled aluminium is not 0, because you need to remelt, to treat, remelt the material, but it needs 5 to 10% of the energy to recycle. Of aluminium should be wasted, and the aluminium industry in Europe and in other parts of the world are working through diverse schemes to increase the recycling rates, and they are quite already high. For example, beverage can in Europe, the average recycling rates are close to 75%. It's not 100, and it should go to 100. And the industry is working on that. So, yes, in essence, it's very important to increase the recycling rates. But even with recycling rates of 100%, there is still a significant need for aluminium coming from primary sources, just because there would not be enough scrap from post-consumer sources available to meet the demand.
Thank you. So anybody who has any further question or comment, please submit them through the question and answer function. There are also some within the chat window, so I will take from them from there. So this first is, when using low carbon aluminium with wood buildings, does the aluminium volume, as in absolute amount, go up? The answer is no. It's like physically the exactly same material. So that should be clarified. There's another question which I believe is more relevant for us, whether in the retrofit case study, does the saving include the aluminium reuse? No, it does not. So it's just a comparison of, apples to apples, both primary aluminium from fossil energy as well as low carbon aluminium are reusable. And there's a comment about handling it in 1-click LCA, and happy to report that in the October update we will also have an enhanced reused modeling capability in the software. There's a question from Philip, which is, what percentage of low carbon aluminium emissions are associated with anode? Do you want to take this, Jerome?
Can you repeat the question, please? And what percentage of
emissions are associated with the anode?
Right. Okay. On the top of my head, I would give you rough numbers. It's between 0.3 and 0.5 tons of CO2 per ton of aluminium, the production of the anode for the pre-baked anode process. Top of my head. So the order of magnitude you can trust, but and of course it depends on the cases and on the smelters. So it's significant, but a minor portion of the footprint of aluminium. This is for the production of the anode. There is also the processing aluminium involves the consumption of the anode that actually is used in the electrolysis, and then the anode is consumed CO2. Then the consumption of the anode is an essential part of the production process and GHG emission of the smelters.
There's a question, are there any other examples of low carbon aluminium made from other renewables than hydro, and what's the prospect of becoming more widespread, considering that hydro isn't widely available in all countries? Jerome, you're from the business itself, so your view, please.
So with respect to, let's say, the potential capacity increase of aluminium production and use of renewable energy, there are not that much projects in the world that are scheduled with renewable energy. The only one is actually from Rusal, is based in Siberia, and with a plant that is named Taichet, that is scheduled to have an increase of capacity of 400,000 tons by 2022. Actually, there will even be some production starting next year. This is very, very limited. Of course, the challenge and what we could see going forward is progressively having a decrease of carbon footprint from existing smelters that are working with the energy providers and together with the energy sector to decarbonize the energy source. That's also what needs to happen. But in terms of pure renewable energy, new project, very limited.
All right, there's a fairly detailed question whether SF6 has been accounted for in the calculations presented. So I can answer that generally. Yes, and SF6 is a special gas which is used in aluminium production as a cover gas. Whether it's accounted in the figures Russell presented, I'll let Jérôme to answer that. So I will answer for the as far the white paper goes. Jérôme, do you want to comment on the SF6?
On the sorry, I missed this point here. Sorry for that.
Yeah, the SF6, sulfur hexafluoride.
Yeah. So yeah, the hexafluorides come from the ingredient that is used in the smelting process, and yeah, they are accounted for the greenhouse gas emissions, of course, and they also, I mean, are a significant part of the process emissions. So they are part of the calculation. Yes.
Thank you. There's a question apart from the Russia, which are the countries in Europe that are producing the lowest carbon aluminium? Jérôme, I think I'll let you answer that.
Yeah, I can answer to this one. So let the major producing countries that have low carbon aluminium are in so outside Russia, in Northern Europe, namely in Norway and Iceland, where they have access to renewable energy, essentially hydropower, and also geothermal in Iceland, and Canada. There is also some production in other parts of the world, in Brazil and in Indonesia, especially in Malaysia.
All right, thanks. What is the impact of LCA on lead points? Lead is important in North America, so I can probably take that one. So life cycle assessment and product embodied carbon has bearing on 3 different lead points. So there's 3 credits in lead: building life cycle impact reduction, environmental product declarations, and new pilot credit, procurement of low carbon construction materials. And altogether, they enable up to 9 points potentially as a maximum. So it's a very significant amount of points. Whether all those points are achievable on a given project, of course, depends on also on other parameters than low carbon aluminium, but that's the total potential, and low carbon aluminium is definitely a significant contributor to those. We also have a question of what's the difference between renewable energy and carbon-free electricity. So nuclear comes to mind. Nuclear is pretty good at, in terms of carbon footprint. It's not renewable though. And, we are, Finland, speaking as a Finn, we are building some nuclear power plants. So in the future, we are mostly going to be wind, hydro, and nuclear as far as Finnish power generation goes. And they do work together, but that's just the carbon point of view of the equation. Of course, there are other concerns regards nuclear. We do happen to have a very stable, geophysics in Finland, so we don't have to worry about earthquakes or that kind of stuff in regards to those. I don't see any further questions. We are inviting any attendees to submit any questions or comments. For our part, very happy that you were active and very good questions and comments. Hopefully all of you found this useful and interesting for your work. And as I mentioned, for those of you who managed to sign up a bit delayed, this has been recorded, and the recording will be possible to access later on. On behalf of BioNova, many thanks for joining, and wishing you a great day.
Thank you very much. Thank you, Panu.
Thank you, everyone. The webinar ends. Have a great day. Bye.
Have a great day. Bye-bye.